Okay, so we're going to start with the law of sines. The law of sines is used when you do not have a 90-degree triangle. So that's called an oblique triangle. You can use this if it is a 90-degree triangle, but it's more effective to use SOHCAHTOA. So this formula does work in all situations, but we have to use it when the triangle does not contain a 90-degree angle. So there's two laws that we're going to learn all together. The first one's called law of sines, and the second one's called law of cosines. There's no such thing as law of tangent, and as you go through math, you're going to learn that tangent is just a combination of sine and cosine anyways. So really, tangent's not its own thing. Sine and cosine are the only two real ones. There. Now, it depends on what information you know, what formula you're going to use. There's always 6 pieces of information. So you have your 3 angles, and you have your 3, so you got angle C, angle A, angle B, and then side A, side B, side C. So there's 6 pieces of information. You have to know 3 pieces of information in order to try to solve a triangle. Now, to use law of sines, you have to have an angle and its opposite side. So we'll call that a pair. You have to know like side A and angle A, and then just one other piece of information. It doesn't matter, like it could be side B, angle C, side C, or side B. And I know I've said this a few times, but we use uppercase letters to name the angles, and then we use lowercase letters. I can't talk today. Lowercase letters to name the sides. For side lengths, we'll go to 1 decimal place unless we're told otherwise, and for angles, we'll go to the nearest whole angle. So we have these 2 versions of this formula. They're really the same formula. It just depends. If you're looking for a side, we usually put the side part up front on top. And if you're looking for an angle, then you put the angle up top. And so what's true in a triangle is if you take the length of side A and you divide it by sine of the angle that's opposite to it, that will give you some decimal. And it would give you the exact same decimal if you took the length of side B and divided it by the sine of angle B. And same thing in this triangle, and like it doesn't matter if we have a small triangle or if we have a huge triangle. If you take the proportional size here, so side C divided by the sine of angle C, those ratios are all equal to each other. Okay? And so it'd be true upside down too. If those numbers were all, like I'll just make up a number, if they were all 3/4, 3/4, 3/4, and then 4/3, 4/3, 4/3, those fractions would all be equal to each other. Now you only ever need to use 2 of these parts at a time. So it might be a situation like this, where you're looking for side A, and you know angle A, you know side B, and you know angle B. When you have an equation, you can only have one unknown. So one equation, one unknown, we can solve for that equation. Okay, I'll get you to copy down this for an example. Just erase this. So we'll do an example of a triangle that's not a 90-degree triangle. So if it's not 90 degrees, we have to use either law of sines or law of cosines, and I'll talk about the criteria for that one later. And I purposely didn't name this triangle because I don't want you to get too hung up on the names of the letters or the sides. But I'm going to write the formula. So this is how I'm going to write the formula. I'm not going to put the other part equals C over sine C because I don't need all 3 pieces to make this work. So I always need a pair. And I have to look and see if I know an angle and its opposite side. So I do know angle 19, and I know it's kind of on a slant here, but it would go, that would be the opposite side to 19. So I always have to know a pair, and put your pair that you know on this side. Then I'm either gonna know an angle or a side. I need to know one other piece of information. And then what the formula will let me do is it will let me find the other part of the pair. So I'll put that over here. So let's put in the numbers. So the x is a side length, and its pair is the sine of 128. And the other pair that I know, the side length is 35.4 centimeters. I'm not going to bother put my units in now, but it would be 35.4 centimeters, and it would be sine of 19 degrees. Now technically, sine of 19 degrees doesn't have units, so once I move everything around, especially if you guys are doing physics right now, the only units would be left would be centimeters, and that's what we're looking for. So there'll always be a pair that you know. Put that on the other side, the pair that you know. Put whatever you're looking for on top with its pair. Okay, so the x would go with the sine of the 128, and the 35.4 goes with the sine 19. Everything happens in pairs. Well, if I want to get x all by itself, how do I get rid of dividing by sine of 128?
Multiply by sine.
Okay, so 35.4 divided by sine 19 times sine 128. This is a side length, so we'll keep our answer to one decimal place. So 35.4 divided by sine 19, and then times sine 128. Didn't really matter the order I did that. And so I got 137.98. Did I take that right? 128. So I guess if I'm going to round off, I should say 138.0. One little piece of information, I've said it before, but I'll say it again. One little piece of information to tuck away is that your biggest side is going to have the biggest angle, or reverse that. The biggest angle will always have the biggest side, and then the smallest angle is going to have the smallest side. Now, I don't know the other angle or the other side or anything to this, but if we did solve the triangle, we would find that to be true. But it makes sense that this is a really big side, yeah?
When I did that in my calculator, I got 85.68.
Okay, yeah,
I got 137, but I didn't get 137.9. I got 137.9.
let me just double check. I'm in degrees. So 35.4 divided by sine 19. Oh, I put divided by. Okay, sorry. Times, I hit the wrong button, sine 128. 85.7. Okay, sorry about that. I'll change this too. The other type of question that I could ask is to find a missing angle. I'm gonna use this version of the formula. When I'm looking for an angle, I put sine of the angle that I'm looking for on top. And when I was looking for a side, I put the side on top. So the nice thing about law of sines, it always goes in pairs. So I mean, if you have a highlighter, break it out. Like, there's always a pair that you know. So a side and its opposite. Okay, so I'm going to put that over here. And then there's going to be one other piece of information. And you're going to have to, like, what the formula will do is give you that other partner that we were missing for the 22. So this time I don't know the angle, and they just called it theta, so I'm going to call it sine theta. Its partner is the 22. Then its angle first, so I'm going to say sine of 32, and it goes with the 15. So everything goes in partners with law of sine. Now what I'm trying to do is I'm trying to get the angle all by itself. What's the first thing I'm going to have to do?
Remove the 22.
How do you get rid of dividing by 22? Okay, so I'm going to just leave this as sine theta for right now. This would be sine 32 divided by 15 times 22. And then I could do that all out now, or how do I get rid of sine? Yeah, what's the opposite of sine if I want to bring that over to the other side? When I'm looking for an angle, what do you hit?
There's sine.
So you're going to hit second function sine. So you could either do that all out in your calculator, then hit second function sine of your answer, or you could just type this all in one step on your calculator. Now be careful with brackets, because when you press, or not everybody's, but when I press sine on my calculator, it automatically wants to open a bracket. So I would have to close that bracket on my calculator when I'm typing it in. So just watch out on your calculator. So I am going to go second function sine of 32, close that bracket, divided by 15 times 22, and then close the other big bracket. And I got 51 degrees. Does anybody need some calculator help there?
Okay, got this.
So a lot of times people's calculators will say when they hit sine, they'll open up a bracket. So you only want sine of 32, close your bracket, then that will make it divided by 15. If you don't close your bracket, if you just say sine of 32, your calculator does that, and then just say like hit divided by 15, then your calculator is thinking sine of 32 over 15. That's what your calculator is thinking. But your angle is 32.
I made that mistake the first time I did it and it said domain error.
Yeah, because to take the sign, then that would probably not work out. Because your answer would be a number bigger than 1. Okay, let's try another one. Let's say this is 110 degrees. This is 45. Let's say this is Okay, so I have a triangle here, and let's solve this triangle. So let's find all the missing sides, all the missing angles. So the first thing you have to look for is if there is a pair. That's how you're gonna know the difference between law of sines and law of cosines. But the ones that I'm gonna give you today do have a pair. What letters are the pair? P. So we have angle P, or actually I'm gonna use a different color just to match my colors from last time. So angle P I know, and side P I know. Okay, so that's the pair that I know. I can fill that information in right now. 42 point. I know angle Q is 28. So its pair would be the little q. And I know nothing about R right now, but we could do a little bit of work to find that out without too much difficulty. So the way that the law of sines is set up is because I know angle Q, I'm going to have to find side Q to get going. So I'm going to find side Q. I know this pair. So I know that, I don't know little q, but I know that big Q is 28. And I know little p, and I know the angle at P. So there's always going to be a pair that you know. And then there's going to be another pair that you're missing one piece of information for. Okay, let's solve for Q. So to get Q all by itself, I'm going to bring that over to the other side and it becomes multiplying. So just careful here, like on my calculator, I have to close that bracket. I have to close that bracket. Some of your calculators are not like that, but I know a lot of them are. So I'm going to hit 42.5. I'm going to say divide it by sine 110, close my bracket, times sine of 28. So I got Q is equal to 21.2. Anyone else get that same number?
Yep.
Okay, so Q is 21.2. Okay, let's put that in here, 21.2. Now R, we didn't know anything about that, but they would go together. What could I figure out?
The angle.
Angle R, because you know, what do you know about all the angles in a triangle?
Is up to 180.
Add up to 180. So take away your 110, take away your 28 degrees, leaves me with 42 degrees. 180, take away 110, take away 28, leaves me with 42 degrees. So I got that number there. And again, I'm looking for a side. So it'll be little r goes with the angle at r. And then I'm going to use that same pair. It's always good to go back to original data. So I'm going to go back to the original data when I'm looking for the r. And that's nice about, like, calculators, like, you can recall, like, I can recall what I just typed there. And then instead of timesing it by sine 28, I'm gonna times it by sine 42. At this step, if you have all this information on your page, and then you just put the answer, that's fine. You don't have to show me like that next step. If you want to just go right to the answer, that is okay with me. And so I got 30.3. Anyone else get that number?
Yeah.
Okay. So we know that this is 42 and this is 30.3. Now a little quick check. I mean, it doesn't guarantee you're right, but the smallest angle should have the smallest side, and the biggest angle should have the biggest side. And that is true. So it's not, like I said, it's not a guarantee, but it is definitely let you know if you're on the right track or not. Okay, sometimes they'll do this to you. Let's say this is 62 degrees. This is 70 centimeters. They want to know this side, but then they're telling you this side is 30. So sometimes they'll just make you work for it just a little bit. First question to ask yourself every time, is there a pair? Which ones are the pair?
62 and 70.
Okay, so this angle and this 70, they're a pair. In order to use the law of sines formula, if I want to know this x, I would have to know that angle.
Oh,
You have to add it.
Right. So I didn't know that angle. They gave me a different angle, but we know that all the angles add up to give you 180. So it's a quick calculation. 180, take away the 35, take away the 62. What does that leave you left over? What is it? 83?
Yeah.
Okay. So sometimes you'll have to do that as a little step first to make sure you got a pair and a pair. It always has to be in pairs. So now we know that if I write it out like A over sine A equals B over sine B. The one that I'm looking for is X. It goes with the 83. And the one, it's side on top, so I go side on top again. 62. And then that could work in the reverse too. They might want it that angle, but I knew the other side or something like that. So as far as like my showing me your work, like we know that sine 83 is going to come up over to the other side. So if you want to save one line of writing, that is fine by me. We're just going to go 70 divided by sine 62. I have to close my bracket times sine 83. So if you want to go right to the answer, 78.7. And our units would be centimeters if we were doing units. Bigger angle, I expect the side to be bigger. Just a little housekeeping thing to keep in mind as you go through that can like save you a little bit of trouble. Okay, I'm gonna give you time to work on these questions right now in class actually. They're in your booklet. So I have a copy of this in my OneNote to. So it's on page, well, it's section 10-9. So it's from the old Principles and Process green textbook. So this is the booklet that we're doing, not the textbook today. And it's 10-9. So exercise 10-9. We're gonna do, number 1A, 2A. We'll do 3, I want one with, 2 angles. And with 2 angles, we'll do 3A. And we'll do 4. So 2 angles inside. 2 sides angle. Okay. I'll go with number 6. Now, obviously, there's a few more questions there if you want to try them. If you try 1A and you get it wrong, maybe you should try 1B as well. Okay, that's what we're going to do for law signs.